Many students find it difficult to apply integration in solving question. Imagine, for example, you're asked to find the volume generated when the plane figure is bounded by an equation. And the only way you can solve the equation is to use integration. Now, what do? Well, in this video, I'm going to show you how to step by step solve questions involving the application of integration using a formula. In this case, we're looking for the volume. And then I will guide you so that at the end of the video, you'll be able to solve this question and any other similar question. This video has to do with integration application and solving the volume generated by a plane figure. So what is the equation or the formula for solving for a question like this involving integration application? Now this is the formula. You have the equation before you. Volume is equal to integral bounded by a to b pi y squared dx. It's volume. And remember, in solving for volume, you had to multiply 3 dimensions. So pi is one of them, and then y squared, making it volume. So how do I use this formula to solve this particular integration application question? Well, it's very easy. Just apply the formula using the equation you are given. Recall, it is bounded from 0 to pi over 4. So you're given a radiant. So the volume will be your A is 0, your B is pi divide 4. This is your pi. You open a bracket for y square. You're given the equation y equals to 2 cos 2x. So in place of y, you're going to write 2 cos 2x. It's squared, so you're going to square whatever you have there, the x. So what's the next step? Let's expand this. This is from 0 to pi divide 4. You're going to have pi. If I expand this, 2 raised to power 2 over 4, and then you have cos square 2x dx. I can decide to remove the bracket so that I have, make it simpler, 4 pi cos square 2x dx. Now, recall from trigonometrical identities, there's a value for cos 2 theta, and that's 2 cos square theta minus 1. We're going to apply this in this particular expression we have here. This is the same thing as if I make 2 cos theta pi subject formula, minus 1 will move to this side and become cos 2 theta plus 1. But what I'm actually looking for is cos square 2x. So here, cos square theta, it's 1 divided 2 cos 2 theta plus 1. So you can put the expression in brackets. Now this has given us an idea of how to get this value, cos square 2x. Now remember, you have 2x in place of theta. So therefore, cos square 2x, which is what I am looking for, will be 1 divided 2 cos. Now instead of 2 theta, because of this 2 here, is going to be, sorry, because of this 2 here rather, this 2x is going to be 4x plus 1. I hope it makes sense. Since there is 2x here, if there was no 2 here, it would be 2x. But because of this 2, it has to be 4x then plus 1. So at this point, you can put in your values back. So you're going to have 1, your 4 pi, which is there already, and then you have 1 divided 2 cos 4x plus 1. And then you can close it, the x. But to make it easier, bring out a 4 pi, 0 to pi divide 4, so that you're left with this, cos 4x plus 1 dx. So at this point, you are ready to integrate. Okay, I have to write this out. Let's make it a little bit simpler to understand. The half will come out so that I can successfully integrate whatever I have here, cos 4x plus 1 dx. So it's time to integrate. Now before then, this will cancel out. So I'm left with 2 pi. If you integrate this, what will you have? Recall, if you integrate cos, it's sine. So this is going to be sine 4x. If you differentiate 4x is 4, so you divide it by 4. If you integrate 1, which is a constant, you get x bounded by 0 to pi divide 4. So it's time to apply this now. This will be, here you have to be very careful of your solution. Now this is sine for the first bracket. 4, my x is pi divide 4 plus pi divide 4. Okay, the minus, I'm going to use the same expression, but this time around it's 0 divide 4 plus 0. So that's what you're having. And this is 2 pi sine divide 4 plus pi divide 4 minus 4 multiplied 0, it's 0. So everything here will be sine 0 divide 4 plus 0. So that's nothing. And this becomes 2 pi. So here, this is pi is in radian, and in radian pi is 180 degree. So which means sine 180 degree is 0. So it becomes 0 divide 4 plus pi. So that's what is left. Here it's sine 0 is 0, 0 divide 4, it's 0, so it's gone. Now let me put that here in this box so that you remember. Pi, it's 180 degree in radian, and so sine pi, it's sine 180, and sine 180 is equal to 0. Sine 0 is equal to 0. So that's how this became 0. And then this numerator also became 0. So when 0 divided by 4 is 0, so I'll be left with 2 pi divided by 4. And if this should cancel out, it's going to be pi squared divided 2. This is the solution to the question. And because it's volume, you put your units raised to power 3 or cube. That's how to solve question or apply integration in solving volumes in a plane figure that is banded. Now, watch the video over again, practice it. It's very easy. If there are further questions, please use the comment section. If there's a question you want me to solve, put it there. And remember to like, share, and subscribe to this YouTube channel. I want to hear your feedback, so please use the comment section to tell me how you feel about the videos. I would deeply appreciate that. See you in the next video.